Hi everyone, we're going to continue with natural log, except we're going to integrate this time. So we know that the derivative of natural log is 1 over u and then chain rule. Okay, so now we have to find that the integral of 1 over u is natural log of u and then plus some constant. And that's what we're going to practice. So let's get some work in. First thing I'm going to do is take my constant out. You're going to see this quite often, and honestly, it can be just a judgment call whether or not you take the constant out. If you're comfortable with it being there, that's fine, but I think it makes things a little clearer. All right, so I see that straight up I have integral of 1 over x dx, which I know is just the natural log of x plus c. Okay, this time I have a definite integral from 1 to e. Well, I already know what this is, I just found it. So I have 2 natural log of x from 1 to e. So I have natural log of e minus natural log of 1. This is 0, this is 1. So I just get 2. Okay, I have another indefinite integral, and this time it doesn't look immediately obvious what the answer is. So I'm going to do a u substitution, and I'm going to substitute the bottom because that's really all I can do here. All right, so I'm going to let u be 2x minus 1, okay, and du is 2 dx. That means 1/2 du is dx. Okay, now I can do my u sub. So I have a 1/2 integral 1 over u du. Okay, that's not too bad. That's just 1/2 natural log of u plus c, and we're going to go ahead and substitute back in. So I end up getting 1/2 natural log of 2x minus 1 plus c. Okay, and you might be thinking, like, how do I know to do that? How do I know that, how do I know what to expect? Like, how do I know I'm going to get natural log for this? Well, pretty much anytime you see a fraction, a fraction or a rational function, I guess I should say, and the denominator is 1 degree higher than your numerator, a lot of times you're going to look to get natural log out of that integral. Okay, a lot of times. Okay, so this is an example of one of those times. My denominator is of 1 degree higher than my numerator, and it looks like the numerator is a perfect derivative of my denominator, which it is. So I'm going to do a u sub of my bottom, and I get 3x squared plus 1 dx. Okay, so I can do my u sub, and this happens to work out perfectly because of course it does. So I'm going to end up with natural log of x cubed plus x plus c. Okay. Moving on. Now I have something that does not look like u sub. It doesn't look like my natural log. Right? Well, we have to try something. Okay, we have to try something. So I can't really split this up. I don't want to distribute the cubes because that'll just make it more complicated. So why don't we try doing a u sub for 1 plus natural log of x? The reason why I would want to try that is, first of all, it's inside the cube. Second of all, I know the derivative of natural log of x is 1 over x. Okay, so that's what I'm looking for. So my derivative is 1 over x dx. Cool. Well, that worked out real well. So I have an integral of u cubed, okay, u cubed du. Okay, notice this was a definite integral though, so I have to change my bounds. So I'm going to do my when. So when x equals 1, when x equals e, u equals, so when x equals 1, I have to plug 1 in, u equals 1. Okay, and when x equals e, I get 1 plus 1, which is 2. So I'm going to go 1 to 2. Oops. 1 to 2. Alright, this makes everything a lot easier. So now my integral is just 1/4 u to the 4th from 1 to 2. So I have 2 to the 4th minus 1 to the 4th, which is, this is going to be 15, so I get 15/4. All right, another definite integral. And again, I have a natural log here, and I have a 1 over x. Okay, so if you don't see that 1 over x, just notice that's in the denominator. So very similarly to the last question, I'm going to let u be natural log of x. And again, it's inside of this fourth power. And also I see I have a 1 over x here, which is the derivative of natural log of x. Okay. We don't really learn the integral of just natural log of x, so when possible we want to avoid that. Okay. So I'm going to go ahead and do my u sub. So I have the integral of u to the fourth power du. I have to change my bounds. So when x equals e and x equals e squared, okay, so u equals 1 and then u equals 2. So my bounds change 1 to 2. Right, a lot easier. So very similar to my last question. So 1/5 e to the fifth from 1 to 2. I have 2 to the fifth minus 1 to the fifth. So this is going to be 31. So 31 over 5. All right, let's move on. Okay, this is kind of a tricky question. Okay, this is kind of a tricky question. I'm going to split this up, and I'm not sure that I would really expect you all to see this, but I'm gonna end up splitting this up. Now, I told you that you're going to want to do natural log when your denominator is a degree 1 higher, and that's not the case here. However, I do see that this is almost factorable, and if, it's really close to x squared minus 4. It's really close to x squared minus 4. And if it was x squared minus 4 and I factored it, then x plus 2 would cancel out. Okay, that's what I see. Well, I can make this into x minus 4 because x squared minus 5 is the same thing as x squared minus 4 minus 1. So that's really how I'm going to rewrite this. Okay, and furthermore, I can split this into two integrals now. Okay, so now I kind of see that I have a natural log thing going on here. Here's where I'm going to factor. So, move over here. So I have the integral from 0 to 3 of, I'm going to factor this. Okay, so this will cancel. Okay, so I have my integral of x minus 2. That one we can do right now. So that's just going to be 1/2 x squared minus 2x from 0 to 3 minus, and here we can do a u sub if you're uncomfortable with this, but really you're just going to end up getting a natural log of x plus 2 from 0 to 3. If you do a u sub, that's totally fine, but if there's no constant in front of your x here, it's fine. You're just going to get natural log of whatever that is, whatever your denominator is. All right, so we can go ahead and plug things in. So 3 squared is 9, so I get 9/2 minus 6, and then 0, obviously, minus, let's break this up into two groups, minus, I get natural log of 5 minus natural log of 2. Okay, and we could simplify this a little more if we really wanted to. We end up getting 3/2 minus natural log of 5 plus natural log of 2. Okay, so big thing, if you are integrating a quotient and the power of the numerator is greater than or equal to the power of the denominator, you must divide. You must divide. And this was an alternative way of doing this problem. And we can actually go over that in class if you want to. I did it a shortcut way, which I think is easier. You're not going to see a whole lot of problems written out like this. If you can't work it out in a nice way like this, which is, because I saw that I ended up getting x squared minus 4 minus 1. If you don't see that, you can always do long division or synthetic division if it works out. You can always do long division. You end up getting a remainder just like this. Okay, so you would have gotten the exact same thing. It's just I think this was an easier way of doing it. Okay, so a couple more integration formulas that you need to know, and you can take a look at these. We're going to prove some of them. All right, we're going to prove some of them. So let's do the integral of tangent. Well, if I just gave you this problem, I would expect you to at least get here, because one of our strategies is rewriting tangent in terms of sine and cosine. Okay, we talked about that all the time in pre-calc. Well, now I have something I can work with. I can let u be cosine. So du is negative sine, so negative du is sine of x dx. Now I can do a u sub. So I have negative integral of 1 over u du. So negative natural log of cosine of x plus c, right? And that's exactly what our integral tangent formula told us. And that's why we just rewrite in terms of sine and cosine and then do a u sub. You can probably guess what we're going to do here, but you might be wrong. Okay, so if we tried rewriting secant in terms of sine and cosine, we would get 1 over cosine, and then we'd be stuck. Okay, we would be stuck. So here's what we're going to do instead. And honestly, I've read why you would do this, and I would never expect you to be able to do this on your own. Just because it's really random to me. But we're gonna end up multiplying by sort of a conjugate, sort of something just that we want to make a substitution. So what I'm gonna do is multiply secant by secant plus tangent. And honestly, I almost don't even want to show this to y'all, but it is important. You'll be expected to know this. I won't necessarily expect you to prove it, but you will be expected to know the integral of secant, and this is where it comes from. So if I have this situation, and I distribute, so I get secant squared plus secant tangent. Okay, now if I make a u sub, and I let u be the denominator like I normally would, it works out really well. So now when I take the derivative of secant is secant tangent. The derivative of tangent is secant squared. So look at how well this substitutes. So I have the integral of 1 over u du. So that works out really well. We end up getting natural log of secant x plus tangent x plus c. So you kind of could work backwards knowing the answer because you have it written for you. Again, I've read why we do this, and you know what, if you want to look into that yourself and maybe you could explain it to me a little better, maybe there's some extra credit in there for you. But to me, this just seems like the most random thing, but that is where it comes from. Okay, last one. The integral of tangent of 3x. Well, again, I can rewrite this as sine of 3x over cosine of 3x. And I can let u be cosine of 3x. So I get negative 1/3 du is equal to sine of 3x dx. So I make my u sub, negative 1/3 integral 1 over u du. So I get negative 1/3 natural log of cosine of 3x plus c. All right, and that is it for this video. I will see y'all later.